Welcome to qnawire.
Here we have to answer the questions shown in the slide. Prior to the answer, let's sketch the exponent function because it's crucial to solve this problem. So let's say our function is V voltage equals to initial voltage multiplied by exponent powered by negative x. So in this case, this function will have a maximum when x is 0. So when x equals to 0, voltage equals to V0, and when x approaches infinity, the voltage approaches 0 but still doesn't touch it. So now we can answer the question. So first, this is the same function as we discussed. Therefore, when time is 0, voltage equals to V1. When time is infinity, voltage equals to 0, roughly. So it tries to approach 0. So next, in the second function, it's a little bit similar, but it's 1 minus exponent. Therefore, when voltage equals to when time equals to 0, this exponent equals to 1. Therefore, the voltage equals to V1 multiplied by 1 minus 1, which is 0. On the other hand, when time is infinity, the exponent becomes 1, so the voltage equals to V1 multiplied by 1 minus 0, which is V1. In question C, so it's we see that it's 1 minus 2 exponents. Therefore, when time equals to 0, the equation becomes V1 multiplied by 1 minus 2 multiplied by e powered by negative 0 over RC. So the exponent equals to 1. Therefore, V2 equals to negative V1. And in the second question, when time approaches infinity, the equation becomes V1 multiplied by 1 minus 2 multiplied by exponent powered by negative infinity. So this is almost 0. Therefore, it equals to V1. And now we can answer question 2, sorry. So we have to identify the cases when of charging, discharging, and switching the voltage. So let's start from charging. Charging means that voltage increases from 1 to some V1. Therefore, we have to find the situation. And basically this is the situation 2. So here V voltage equals to V1 multiplied by 1 powered by V1 multiplied by 1 minus exponent powered by negative t over RC. So again, as we've shown, when time equals to 0, voltage equals to 0, and when when time equals to infinity, voltage equals to 1, equals to V1. Okay, so we found charging. So let's summarize it. Then discharging. In the case of discharging, voltage decays from the initial voltage to 0, which corresponds to the first case. So this is discharging. When the voltage equals to V1 multiplied by exponent powered by negative time over RC. Probably I should use a different color. So again, when time is 0, voltage is maximum. When time is infinity, voltage is 0. And the last case is, in the last scenario switching, it's equation C. Again, V2 equals 1, V1 multiplied by 1 minus 2 exponent of negative time over RC. So again, when time is 0, voltage equals to negative V1, but when time is infinity, voltage equals to positive V1. So as we see, the sign has been flipped. So this is the answer to this question. I hope I helped you. Thank you very much for submitting it.